This week on LCARA Ham Radio, we're going to take a look at the Comet CAA-500 Mark II Standing Wave Analyzer. We're going to put it through its paces, show how it's a little bit different than some of the other analyzers that are out there, and then we have a special announcement at the end of the video. That's what's coming up this week on LCARA Ham Radio. Alrighty, so let's take a look at the box that it came in. The Comet CAA-500 Mark II was an analyzer that KY4CKP and I had seen about 2 years ago in Huntsville, Alabama. And at the time, because of COVID, there weren't a lot of these available. So we went back to Comet this year and said, you know, we'd like to do a review of this unit. And they sent over a unit for our review. Again, we'll have a special announcement on this unit at the end of the video. So let's take it out of the box, and KD6FTR is the hand model that we're using for the unboxing. There's your power cord, and it's just like the one, or very similar to the ones that we use with some other analyzers. Here's the instruction or registration booklet, I'm guessing there. And then we pull out the very lightweight usage manual. In two different languages, Japanese and English. I don't know how to read Japanese. I know a little bit of Japanese from some time that I spent over there. But there is an English section, so thankfully we didn't have to read the Japanese side. Now, this booklet is pretty lightweight, so there's a good chance you're going to go back to the website and get more information. The other good thing about this unit, though, is if you've used other analyzers, it won't take you that long to figure out most of what it's capable of. There are a few features on this analyzer that aren't obvious. So now we're going to take it out of the cellophane, and there you go. And one of the striking features about this analyzer that we liked using was the analog needles on top and the digital display in the middle, which isn't currently turned on. So it's at this point we turned it over. We're looking at the back side of the unit. That plate that you see there is to cover the battery compartment. So we got our trusty screwdriver out and we opened it up. And as you can see here, it will take 6 AA batteries. So if you wanted to use the internal batteries, you can use alkalins, the Energizer types, and nickel metal hydrate. If you use the nickel metal hydrate, you can also charge those inside the unit. There's a little switch there that we briefly got a glimpse of. So we connected a little voltmeter there to a battery in AC4DM's garage. He has this around for these kinds of projects, and we just wanted to check the voltage, and then it's just a matter of connecting the battery to the Comet analyzer. And so the hand model comes back over and powers on the unit. You can see the needles up at the top go to the goalpost position, and that's because we don't have anything connected to it at the moment. And then down at the bottom, you can see the digital display. And that's one of the striking features of this unit. You have analog needles, which are very precise. You also have the digital display that can show you multiple types of information. So we go ahead and put on our trusty dummy load because we wanted to play with it a little bit, start learning all the knobs and buttons. So AC4DM created a 50 ohm dummy load. We have a hands-on project coming up where we're going to build something similar. Now on the VHF-HF side, it utilizes an SO239, and that's what his dummy load accepts. On the UHF side, it uses an N connector. So here we're just looking at the analog needles, 50 ohms is what we would expect, very near that. And the digital display is essentially showing us the same information. All Alrighty, so let's take a look at this digital display. Now, you can kind of think of this as the home screen. We're going to show you how it can also graph your SWR across your frequency range. But we have the frequency up at the top, plus your battery level indicator. Below that, you've got your band select, and you'll notice a little red tick on the top left corner. So right now, we're looking at 1.8 as our band, 1.8 megahertz. If you go across that horizontal bar there, you can see we go to 3.5 all the way over to 430 in the right. Below that, we have our SWR indication. We've got a bar graph showing 1.1 at the moment and just a tiny slice of green on the far left underneath 1. But you can see it can swing all the way over to the right to something greater than 6 over in the red section. And so that section is labeled SWR with the little green square. Below that, we have our ohms, which would check whether or not our resistance on the cable going up to the antenna would be correct. And you can see with this dummy load attached at 1.8 as our frequency, 1.8 megahertz, we're looking at about 57 ohms and no reactance at this point. So that's your basic home screen, which is really valuable in addition to the needles up at the top. Now we move on to the top of the unit. We were just talking about installing that dummy load. We have an SO239 on the left, and on the UHF side we have an N connector. A button we also have right there in the center where our hand model just pressed is the time off time, if you will, and you can adjust this from, I believe, 0 to 10 minutes, somewhere in that ballpark. Looks like 0 to 9 minutes, excuse me, as far as an automatic power off to conserve your battery. So now we press the bottom button, and you can see that this is called a graphing option, and you can actually take a look at the SWR not only on your analog meters as you go across the band, but it can also graph your SWR. And the top button is the actual sweep from center. You can set your frequency, and then what it will do is it will graph your SWR. In this case, it looks like 25 megahertz to the left, 25 megahertz to the right of whatever you set as center, and you can see that it's graphing the SWR across that frequency. Now again, we've got a dummy load attached here, so it's not necessarily accurate, but it is showing the functionality of the unit. And with another button press, we can also see what version of the firmware we're currently running on the unit as well. So just a few of the screens. Now, another really cool feature of this unit is to look at your individual bands. You can go into a mode here where you can see here we're at the bottom of 1.3 all the way up to 6.8, I believe it is. This is band A. You've got bands, as we'll see in a couple of screenshots here, where you can go and adjust your frequency, and you can also look at your SWR as well as your resistance, hopefully being close to 50 ohms. Our hand model here has moved up to band B. He's going to go to band C. You can again adjust your knobs to see where you are, and this would be really handy if you have a multi-banded antenna. You can move between the bands here on the meter quickly and then adjust your frequency and then look at your SWR as well as your resistance. So this was really handy. You can go through a number of bands on this particular unit from 1.8 up to 500 megahertz, and what it'll do is it'll chop it up into the various bands so you can focus on that particular band. And again, you've got your digital display showing your SWR and your ohms, as well as the analog display up at the top. Now he's gone up to band G here. That's on the UHF side, so your goalpost position on your meter, but your digital display down at the bottom, and then we're back to band A. So this ability to focus on a particular band comes in quite handy. So our next experiment was to actually attach an antenna. Now, this is not the way to go about it. This doesn't have a ground plane, but what was interesting was to look at something other than a dummy load, and eventually we're going to hook it up to an antenna properly, but you can see how the display has changed. We're looking at an SWR that is not wonderful. From an ohms standpoint, we were pretty much right where we wanted to be, maybe just a little bit low. But this shows you once we did connect an antenna, 2 meter in this particular example, that we started looking at some numbers. Now again, not the proper way to do it, but connecting that antenna was just fun to do. And again, as we learn how to utilize the knobs and buttons on this particular unit. Coming up, we're going to be heading outside to hook it up to some real antennas. So Don has a 2-meter antenna. He's got several, but this is the one on the back side of the garage. So we're going to connect the analyzer to an antenna that he's already got up that's got proper radials and so forth.
That's where we left off last.
Look at that. How about that for SWR?
Yeah, look at that, huh? 50 ohms on the money almost. And we're...
Could you communicate on that?
Now let's do a sweep.
So at this point, we ran a sweep. I had to turn down the audio there because we had a radio in the background, but this is one of the cool things about this unit. Not only do you have the analog needles very accurate, but now it'll run a sweep across your middle frequency, which for us was 146 and some change, and you can watch the needles move as we move across. Now, not a lot, because this antenna is so well tuned that it only moved towards the very upper end of the 2-meter band. So now we're going to move outside. Now this is in my truck. I just installed a brand new mount for my F-150. Now these are aluminum trucks, so you have to get a particular mount to, in this case, mounts just in back of the center high brake position. But I hadn't had a chance to hook up a meter to the Comet antenna that we're using, a Comet antenna that I've used for quite some time, but not in this way. And so we hooked up the analyzer, and if you're looking at the resistance there and the SWR, it's coming in very, very well on our repeater frequency, or very close to it. And then here coming up momentarily, we'll run a sweep. But this is where you can actually start seeing the two displays basically agree with one another, but it also will give you an idea of, is your mounting going to work? Some antennas are very susceptible to where they are mounted or how they are mounted, and then here comes the sweep. So we use the middle frequency of our repeater. You can see it's as flat as it can be. It's actually very well suited to that particular mount, and as far as the SWR, about 1.2. So now we're going to move over to the 440 side. Now again, we had to get our adapter. That's an N connector on the Comet, and then we'll plug in the antenna cable. Same antenna, same setup on the truck, but we'll be looking at the 440 side. Now we have a 440 repeater. I've been able to get into it just fine, but you're kind of flying in the dark, so to speak, without instruments if you haven't put a meter to your antenna, because you may find that you're getting some unwanted SWR. So we turned the machine back on. We moved up to UHF on the digital display, and our hand model is dialing in a frequency close to our repeater frequency. And as you can see, SWR is about 2.4 in that position. And the resistance down at the bottom wasn't quite 50, but close enough. So you can see the SWR is in the yellow. Now, does that mean it's going to blow out your finals on your radio? No, but it's not as good. This antenna could be tuned better for 70 centimeters. And so that's why you hook up a meter like this, is to see if you need to do some tuning. Sometimes these antennas need a little bit of tuning when you take them out of the box and put them together. And then here's the sweep of 440 utilizing a frequency close to our repeater frequency, and you can see it's below 3. And we get a little bit of a downward trend, and then a ripple up above 2, downward again as we go across the band. But down where our repeater frequency is, pretty close to it anyway, it's below 2, which again is workable, but is it tuned as well as it could be? And the answer is no. So one of the other things I wanted to do is kind of show you the analog side of this as well. As we do our tuning and so forth, you can see those needles are moving as they should as we go up and down the band. We're a little high here, but being able to see both the digital display and your needles. Remember, up in the top section, your SWR and your ohms needles there are actually more accurate. The digital display is very good and should be very close to what your needles are showing you, but according to Comet, the top section is the most accurate indication of your SWR and resistance. Now we're going to move over to KD6FTR's truck. Now, he's had his antenna up there for a while, but we thought, well, let's take a look at his antenna, which is a tri-band antenna. And we can look at 2 meters, 220, and 440 over on his truck. So we're going to hook things up and then take a look at the displays. Alrighty, so we have the unit on. We're going to adjust our band using the band knob. Going to go up to 2 meters. And then once you're on your band, you can use the frequency knob to dial in your frequency, whichever one you feel would be appropriate. Probably for your repeater, but it could also be for a frequency you might be using for simplex. So at the bottom end here, we're at about 2.2. Take a look at the resistance and the reactance there at the very bottom. 24 and 11, but as we adjust that knob, you're going to see the blue bar start moving in the right direction, and you'll notice the green bar showing the SWR is also moving in the right direction, going down as we get closer to our frequency or our operating frequency, let's say for our repeater. So here his antenna is showing pretty good setup and tuning for 2 meters. As he continues to adjust the knob, you can see we're approaching 50 ohms. So that's pretty close to the repeater frequency there. We're at about 1.2-ish for the SWR, and the ohms are at about 48. And that's a combination of resistance and reactance down at the bottom, achieving that close to 50 ohms. So his antenna's in a pretty good spot there. And then we just thought, well, why not run a sweep, since this analyzer can do that, and sweeps are always fun to look at anyway. So there it goes. You can see it's dipping down towards the repeater frequency. Flattens out. Down a little bit more. A little bit more. So as we come further to the right, you can see that it's actually tuned pretty darn well. Your needles can show you that if you're watching them as you go across the band, but it's nice to visually be able to see the graph, and that's what makes this analyzer stand out. Now we moved up to 220. He's got a tri-band antenna, so we're looking at 220, which I couldn't do. We're just running a sweep here. Just curious. Looks like we're 10 megahertz on either side of this frequency. Nice dip there. Coming back up though, so it's actually tuned a little bit low, at least compared to the center frequency that we established at 226. But again, everything was below 3 until the very end there. And we're looking at, again, the analog needles at the top. So now it was time to come back indoors, and we wanted to take a look at an HF antenna. And of course, AC4DM has an antenna already set up. So we wanted to take a look at several bands on his antenna. I think it'll work 6 meters all the way up to 80, although you could check 160 as well. And we just wanted to take a representative sample of some of the frequencies just to see how his antenna was set up. And of course, it was practically, pure and perfect, as you would expect, as he knows what he's doing. But utilizing this, again, we could switch between bands quickly and check them, and even run a sweep on them quickly. And that's what makes this analyzer so handy. The combination of knobs, the analog portion at the top, the digital portion in the middle, allows you to jump between bands, not only look at your SWR and your resistance, but then run that sweep, all in a fairly large unit that's easy to read compared to some of the other units that are out there that are relatively small. So here we're looking at 80 meters, or at least achieve somewhere in the middle. And we wanted to get a feel for where his antenna was from an SWR standpoint. And it was actually in a reasonably good shape. Keep in mind, a lot of these longer antennas where you have multiple bands available to you may not be 1.0, but is tunable. And most of your modern radios today, as long as you can keep it below 3 from an SWR standpoint, you can tune it with no issues. But here, we're comfortably below 2. and therefore it wouldn't need a whole lot of tuning. You could certainly do so. We also selected a couple other bands just to run some sweeps. And again, just curious. I don't know if Don had hooked up a meter to his antenna in quite some time. He was very confident that it would be where he needed it to be. And once again, you can see on 40 meters here that it's a little over 2, but again, very easily tunable by a modern transceiver. Here we're looking at 20 meters, running another sweep. And this one is comfortably below 1.5 most of the time, so in really good shape. Keep in mind the analog needles at the top are actually more accurate than the display down at the bottom. They're not tied together, they're using slightly different sections on the board. And then we jumped up to, what have we got here, 10 meters? So double checking a sweep here, 1.5-ish. Hard to complain about what we're seeing here on not only the digital display, but also the needles. But being able to create that sweep is really, really nice. So would this be an analyzer that I could recommend or that we would recommend? And the answer is unequivocally yes. For the money, this provides more functionality than some of the other analyzers that are out there. With the digital display, there's the opportunity to provide the sweep and so forth that you don't get with analog-only displays. On some of the other analyzers that are out there, they have a display, but not the more accurate needles sometimes, like we have on this unit. So this gives you the best of both worlds. And so we're really, really happy with this unit. Had a lot of fun playing with it and creating the sweeps, watching both the needles and the digital display down at the bottom, and we felt like could be a handy piece of kit for anybody's environment that might be out there. Now, are there some things that we would like to see improved? Answer to that is also yes. We would like to see a way to not only create the graphs and create those sweeps, but then export that data. If there was some way to build in a USB port and a little bit of memory potentially, we'd like to be able to export some of the information that you're seeing on the digital display. Outside of that, pretty pleased with it. Now, glad you waited to the end of the video. We are approaching 5,000 subscriptions. We want to give away this particular unit. Again, this was supplied by Comet. We didn't pay for it, and with the idea that we were going to give this unit away, and we promised to wipe off all fingerprints before we give it away. We will do a giveaway video a little bit later after this video comes out. So if you're watching this video after the fact, apologies, but we are going to give this unit away. So stay tuned for an upcoming video where we will in fact announce the giveaway and then eventually give it away. For the Lake Cumberland Amateur Radio Association, I'm KY4 BDP Brian. We hope you've enjoyed the video. Click that subscribe button, the notification bell, and the like as well, and put some comments. If anybody else has this analyzer out there in their environment, tell us what you like about this particular analyzer. Take care, everybody. And 73.